Okay, let us start our class. Good afternoon to all. Today we are going to discuss the rating of motor. So earlier, before discussing, earlier we have seen the some of the contents which are related to our utilization of electrical energy. Utilization of electrical energy. In that, we have seen some of the topics like what is in a drive, what are the electric drive, so what are the type of the motors you have used for your purpose, and you have seen different types of characteristics, that is running characteristics and starting characteristics. So for the different motors, what you have used here, uh, and you have seen the some of the methods which are used to control the speed of your motors. That depends upon the nature of the supply. That's AC and DC. So under the DC supply motors, you have seen the DC shunt motors, DC series motors, and DC compound motors. Whereas coming to the AC motors, you have seen the induction motor. So you have studied both the characteristics for the both the machines, for that is DC machines and AC machines. So that running characteristics and starting characteristics for induction motor also. So you have seen some of the speed control methods, that be a classification of two types, two methods, that is field control methods and armature control methods. So what are the methods which we have seen at the side of the field control? So those are classified under the field methods, and at the side of the armature, this has been considered as an armature control methods. So these are the some of the steps we have to need to select in a motor for your purpose. Now, another important factor while considering the machine that is in a motor for your industrial purpose for a particular drive. So there is another another factor called rating. So here you should have to choose the motor ratings while you use it for your particular applications. So this how it is going to be happen. This selection of motor is completely depends upon the size of the motor. So for domestic purpose, we are going to use just a small motor which is used for having an to fill the overhead tank. So there we don't need any high voltage and high size of the motors, high capacities. So just depending upon your supply to the household, that is for single phase 230 volts, single phase 50 hertz AC supply at around 6 to 8 amperes. So for three phase supply, it is on a 415 volts, 50 hertz, and 8 to 12 amperes. So that based upon your type of supply, you are going to choose the motor. So based upon your particular applications, you are going to select the motor that depends upon the size of motors. So how you are going to select this size? So it's completely depending upon the two factors. So that is maximum temperature rise for the given load and maximum torque required. So before going to discuss or before going to learn about these two factors, so how this motor is going to be taken into the consider. So the temperature rise is always depends upon the type of insulation used. So here, first of all, that temperature what we have going to measure regarding your particular application of your motor. So that size of the motor is depends upon the type of the insulation. So here, what is here temperature means? The temperature is happen nothing but due to the losses occur in the motor. Due to the losses occur in the motor. So various losses which was happened in the motor while in the while for the different types of loads, that various losses are going to convert into the heat. So the raise of that heat for a particular given load is going to be considered. Okay, so for thing the completely so the first point is saying maximum temperature rise for a given load. So that means the completely the size of the motor depends upon the sorry the temperature rise of your motor, whichever the size of the motor you have taken for this factor, it's completely that depends upon the loading. So for just for an example we will see, if you consider a motor at the no load condition, then what will happen to the temperature rise? It will just transfer from outer part to the, that is nothing but insulation to the outer part to the insulation point. So if you keep a load on the motor, then what will happen? It will, the temperature is going to raise at the windings. So these are something, some of the things are going to be happen. That's completely depends upon your given load. So it is also depends upon the how much the torque is going to be required. Now maximum torque required. So let us see the first point, the temperature rise of the motor. So here also the temperature rise will be depending upon the two following factors. That is the amount of heat developed internally at uniform rate and the amount of heat dissipated from the surface of the motor. Yeah, this is the thing I have said as an example. Wherein in the unload condition, the heat is going to be transferred from outer part to the insulation point. So by keep on putting the load to the motor, then it is going to be transfer the heat or raising the temperature at the winding sides. So what will happen? The temperature rise will be high. When it will be? At the time of starting, and it will be decrease, keep on running. At the time passes, the temperature is going to be decreased, and at particular point, it is going to be steady. So you are going to get a steady. Here that is nothing but here amount of heat developed internally at uniform rate. So whatever happens, please hold on.